Welcome. I'm Alex Bohanik, Curator and Senior Manager here at the Computer History Museum, and welcome to our talk today from the CHM Soundbite series, the Totalisator, an algorithm that led to an industry. I'm happy to see so many familiar faces and a lot of new faces too. Who's here for the first time? Do we have any first timers up? Welcome, welcome. Who's been here to these Soundbite lectures before our evening lectures? Good number of people too, great. Well, I think it's going to be a really interesting talk. Totalizators are one of those technologies that are relatively little studied but hold some great fascination. They're large mechanical devices, and you saw earlier the Babbage engine in our intro film, and certainly these types of mechanical computing devices are quite fascinating, not just as antecedents to electronic computing devices, but also in their own right for what they represent, some of the solutions that they produced. And when you have a chance to go to the Revolution exhibition, you'll see in the calculator galleries, analog computing, punch cards, a number of ways of how to do computational calculation using mechanical components. And I think the Totalisator certainly is part of that history, and I'm very excited that we have a talk on it today, and in fact have two Totalisator adders in our collection. One of them actually you see right next to me here at the bottom of the stage. 2013 is the centenary of the installation of the earliest large-scale automatic totalisator that was installed at the Auckland Racing Club. George Julius invented this particular machine that was as I said, at the Auckland Racing Club grounds at Ellerslie for the Easter meeting in 1913. And let's just kind of think about that time. 1913 was when the moving assembly line was introduced at Ford Motor Company. It was also the year before Thomas Watson joined the company that was to become IBM. So we're really looking at some of the early days of computing there. Electronic computing pioneer Maurice Wilkes was born in 1913. It was also, of course, the eve of World War I, and perhaps from a different view, the 1913 International Exhibition of Modern Art introduced modern art to the United States. So that's sort of the time frame we're talking about here. The speaker today is Bob Doran. Bob is Professor Emeritus of Computer Science at the University of Auckland in New Zealand, but has a long connection with Silicon Valley. He graduated from Stanford with a master's in computer science in 1967, and had also worked at Amdahl Corporation from 1976 to 1982 as a computer architect. I think like many people who are in the computing field, Bob has a long fascination with the history of computing. And in fact, our roots as a museum are linked to that fascination too. I'm sure everybody who's been here before knows our connection to Digital Equipment Corporation and some of its principals' fascination with their own history. So Bob will introduce us not just to the Totalisator as a device, but also to the origins, the Pari-Mutuel betting system in the 19th century as it developed, how it was implemented using mechanical means, and then the eventual replacement using electronic computers. There are cards at your tables and on your chairs for Q&A, which we'll have after. So please hold your questions until then. And now let's welcome Bob Doran, Totalisator, an algorithm that led to an industry.
Thanks very much for the introduction, Alex, and thanks for everybody for coming along. How this happened is that I've been trying for a number of years to get the Computer History Museum to take some of the relics of the Australian totalisator industry, and they agreed to, and this year we managed to get the two adders, one of them in the lobby downstairs, and the other one there, which I managed to get in my luggage coming over to have a look at the wildflowers in the Sierras, so I delivered that one by hand this morning. And I just thought that as I was delivering it, I could give a little talk which would describe the background of the totalisator and put it in context. When it comes to the actual talk here, how did I get involved with totalisators? Well, 10 years ago, our department got a new building, the computer science department, and we made a timeline. And I knew that Auckland had the first automatic totalisator in 1913, but I had no idea as to what it was. And I searched around and I found a few photographs, among which was, oops, I certainly got fast forward then. This isn't meant to happen. Okay, a bit further up is that's what I'm looking for. This picture here I found, photograph. And looking at it, I didn't have a clue what it was, no idea what it did, how it worked, and this was a source of fascination to me because I just had to work out what it was. It's just a huge machine. And so for the past 10 years, off and on, I've been looking into the history of this machine, how it worked, and this led me to some interest in the history of the totalisator itself. Now, to understand the totalisator, we have to go back to the mid-19th century, and, well, that's a brief summary of what I'm going to talk about. But so we are going to talk about the stuff before the Auckland machine and a little bit about what happened afterwards. Let me get back to the history. And it all happened in the mid-19th century, and basically it was the fact that the Industrial Revolution, although it caused a lot of disruption, led to lots of people who had money to spare. And one of the ways they got rid of it was by gambling, and horse race gambling was the game that they were most involved with. So there's a great growth in the horse racing in England, particularly that it spread onto the continent. Now, to start with, the gambling was usually either between friends or you went to a bookie, which I'll mention a bit about later, or they have what we'd nowadays call an office pool, where there's one ticket for each horse and people are given a ticket at random. And so that was the initial forms of gambling. But there was a guy who had a better idea. So I've got to introduce the first of the three important people I'm going to talk about today. And this is Joseph Auler. And he's a Catalan origin, living in Paris. His father had a factory there, so he was brought up in Paris. And he invented the what's called the Pari-Mutuel betting system, which we're going to talk about. But he's better known as an entertainment entrepreneur and impresario. In fact, you might regard him as the Bill Graham of his age. There's an autobiography, a biography written about him called L'Homme de la Belle Époque, I think I got it. So in the 1890s, he was the man about town, the man you wanted to know. And he was the co-founder of the Folies Bergère and other shows. But earlier in his career, his father sent him to Bilbao to learn Spanish, because he spoke Catalan at home and he brought up with French, and he thought Spanish was necessary for business. And it wasn't a good idea, because it turned out that in Bilbao they spoke Basque mainly, but young Joseph spent a lot of his time going to the cockfights and seeing how people laid bets with effectively a bookie, and the fights and the concern that would happen when bets didn't happen as they expected. So he invented a method of gambling. Forget about the mathematics. All you did was you decided to take bets in terms of a smallest unit, and as you took bets on each particular, I'll go to horses now, particular horse, you would increment the total of the bets on that particular horse and increment the grand total. And when the betting had finished, the horse race was run. There'd be a small commission taken off the grand total, and the number of bets on the horse that won would be divided into the grand total to give the dividend per unit bet. So a very fair and simple way of doing things. And that's Auler's idea. You may think it's silly and trivial, but somebody had to invent it, and Auler was the person who did it. And I regard that as an algorithm. Simplest way of regarding it is a serial algorithm. You're getting one bet at a time and you put it on one of many horses, and it can be parallelized as well. But that's what it is. It's an approach to gambling which involves an algorithm. So Auler went back to Paris and he started his own business involving betting. And initially they used pool-type betting, but he introduced the Pari-Mutuel form of betting, which is French for betting among ourselves. And he had a central office inside Paris, and when they had a race in one of the many racetracks in Paris, they would go out to the tracks in their large wagons and take bets and so on. Later on, he made the whole business much more interesting by displaying the number of bets on each horse as they were made. So all the punters could keep an eye on what everybody else was doing, and that would influence their betting and increase the interest. Now, Allaire introduced this thinking that pool betting is pure gambling because you get a ticket at random. But in the case of Pari-Mutuel, you've got to think about which horse is going to win, and this involves skill, so it was a game of skill. But when it was tested in the courts in 1875, it was banned. Allaire actually spent a short time in prison, and they kept the ban up until 1987, when they allowed it again. But it was a great idea, and it spread. Well, this is one of the wagons. We have a few pictures from the newspapers at the time, engraved woodcuts most likely. It shows the nature of the wagon. It's a bit like the Wild West, isn't it? Wells Fargo. And with a few things added on. The display of the various totals of bets that are up there, and windows for taking bets and that sort of thing. So it spread, and the first record I can find of it is in Germany in 1871, in Hamburg. They were running Pari-Mutuel betting, and other countries took it up as well, but for some reason the name changed, and rather than Pari-Mutuel, it became called the Totalisator, which is strange because the French don't use the word, but it's based upon a French word which means counter, Totalisator, I suppose, which is a counter. And all a totalisator is an implementation of Euler's algorithm. You don't need Allaire's algorithm. You don't need any machinery. You can just do it on a slate, on a piece of paper, or whatever. Now, I'm particularly interested in what happened down in the southern hemisphere, and the first mention of found of a totalisator is in Sydney in 1878, but it involved machines now. They were imported from Germany, and people tried to get them going and have betting that way, but in Australia, they were banned. The bookies, the other form of betting, were too strong. But in New Zealand, on the frontier, they were allowed, and they started in 1879. And these were small machines which just recorded the bets by incrementing a mechanical counter for each horse and a grand total. So here's some examples of these early machines. That one is in the museum in Auckland, and it's just in the process of being restored. It operates with a foot pedal. Person wants to put a bet on the horse, you depress the appropriate pedal, and the counter for the horse increases, and the counter for the grand total at the top there, that increases as well. A bell rings, so the punter knows that the bet has been registered, and it keeps on going until the start of the race, and they then work out the dividends manually. There's a couple more of them. In fact, there's only 5 of them that I know of in existence. There's 2 in the stables of the Auckland Racing Club. There's one very handsome looking machine. And this one here I call a personal totalisator. It only works on 10 different horses and needs a bit of repair, but it's a beautiful machine. And there's 2 further south in Dunedin in a museum there as well. So they're the only ones in the world as far as I know. You may wonder why you have machines. You don't need machines to run the totalisator. Well, it seems fairer from the point of view of the person who's making the bets than having to deal with bookies. The bookies are the people who offer fixed odds in gambling. And you always worry when you have a bet with a bookie that you're getting a fair deal. But bookies is a very simple thing. You actually have a fixed contract. If the horse you're backing wins, for example, you'll get paid 2 for 1. And it's very clear and obvious what you're doing. Now, the totalisator is actually prone to errors because you've got to keep track of the totals of the bets. And this can be accidental or they can be deliberate. The people operating the totalisator can make up bets on horses and therefore reduce the dividends which get paid out. And the machinery, I think, gave confidence that the additions were made by a piece of machinery in front of the people who were betting. And they had other safeguards to reassure the bettors. The bookmakers I've mentioned once or twice, they have a bad image, and it's a later image of a bookie in the 1930s, and there's something a little sleazy about them, but they still operate. And last year I happened to be in northern Queensland, and the day where they had the Cairns Cup, and there was still, keep on pressing that wrong button. I'm pressing that way. There we go, back again. And so there's a whole bunch of bookies offering fixed odds on the horses in the Cairns Cup, and it was very interesting to see that. They also had a totalisator. My wife put a bet on this horse here based upon the stars on its rump, number 3, and it came in first actually, so it was a good system. But really with horse races nowadays, it's more about fashion than anything else, and there's a typical piece of millinery for a horse race. So totalisators seem to give confidence, but it's not justified because the operators of the totalisator can play all sorts of tricks. And in Auckland, the very first time they were introduced, they made up bets on outsiders to reduce the dividends. And it's only fair, a totalisator, if it's operated by a trusted agency and audited. So in New Zealand and in most countries, the legislation had to be passed for operating totalisators. In New Zealand, the monopoly was given to the racing clubs, and they could operate totalisators, but they had to have government employees there to check that it was done properly. And the government, of course, has a tax on the gambling, so they have to make sure that they get their fair share. In New Zealand, bookies were banned, and this was great because it gave the clubs the monopoly of gambling. And it was really the only game in town where you could gamble. And it enabled them to give bigger prizes, which encouraged the bloodstock industry, which is quite a big thing in New Zealand. And initially, the totalisator consisted of those off-the-shelf machines run by a local person who was sometimes called a turf accountant. Now, I've got some pictures of the buildings for these very old machines. This one in a little town called Wanganui. And you'll see here 2 machines, one here and one here. And this is the crew probably getting ready for a race. This guy up here runs it. And he got a percentage of the takings. He's actually my great uncle, I discovered eventually. But he became very wealthy, as they tended to do, and built the Grand Hotel and was mayor of the town. And, it's a good thing to do, to run a totalisator. I've got a few others here. There's a guy in Auckland called Harry Ha. He ran it away from the racecourse. And you could probably look as you could trust him with his Homburg on. And there's some, well, lots of these things around, probably hundreds of them. And on the left-hand side there's a racecourse at a goldfield. And you can see it's just a rough building and really rough-looking people as well running the tote. And this is an agricultural town further north. They tended to make nice little buildings like that to house these totalisator machines. And I found one remaining building in the defunct racecourse in the middle of the country, and I've got a feeling that might be one of them as well, but I haven't really found one. Okay, the problem with these individual machines is on a big racecourse, you need a lot of them. There's one Auckland racecourse, I saw a statement, they had 11 of these totalisator machines, and I'm sure there were a lot more on the bigger racecourses. And they were often next to each other, and there were multiple sales clerks, and you had to say what you were betting. Everybody knew what your bet was and what a sucker you were to put a bet on that horse. It was very noisy and no privacy. And you can't just have one machine because everything wants to happen at once. Everybody wants to lay a bet, and so it's a bottleneck. So you needed a much larger parallel machine. And somebody had the idea that you didn't need any machinery, but you could actually run a totalisator as a building with people inside it. So that was the next step. It happened in the first part of the 20th century. Actually, the first building I found, it was in Brisbane, but that was a bit different. That was a guy who made a machine which used marbles or ball bearings to represent bets, which ran down tubes and so forth. So that's an entirely different story. But that may have been the idea, because these things happened. And there's a totalisator building in Christchurch in 1913 as well. And here's one in the early 1950s in another town. So they were very popular form of entertainment because there wasn't much else around until we got TV and so forth. Okay, so what are these tote buildings? Well, I don't think it's too far-fetched to regard them as computers themselves because they follow the algorithm, execute an algorithm, which is Euler's algorithm. They perform arithmetic. You've got to do a bit of division to work out the dividends. They have input and output. They take money in and they give money out. And they have a graphic display showing the totals. So I think they're computers. They're special purpose ones rather than general. They're run by manpower rather than electricity. I say manpower because women were banned from the totalizators because it was considered unseemly for them to be in the room with all the men. But the interesting thing was, although they were there was no machinery really at all apart from some display machinery, they called them machines. It was called a totalizator machine, but it wasn't. So I kind of regard it as a big PC in a way. This may seem far-fetched, but in the 1980s, when computers were fun, there were books to tell kids how computers worked. And one model which was used was that the computer really consisted of all these little men, and women, oops, go back one, and women there, inside the machine who were doing all the work. And there's some guys on the left there doing some calculations and some on the blackboard here. So that was how the computer worked. There was all these little people inside. And they even had the display working that way. Somebody gave instructions to an artist who was drawing on the screen. So it is not too far-fetched, I think, to regard them as computers. And how did they work, these things, these big buildings? Well, some points. I'll show you some pictures. The tickets for the horses had large serial numbers, and you could tell from looking at the serial number how many tickets had been sold. And there was a guy behind a group of people selling tickets called a computator. That was the word they used. And the computator would add up the sales for each horse for that group of ticket sellers and write them on a blackboard. And then somebody else would take those totals and add them together to say maybe to give the totals for 16, for example, sales machines. And finally, the grand total would be formed by somebody who'd read all the blackboards from those people. And then the operator of the display would read the final numbers and display them on the display for people to look at. Later on, they displayed dividends rather than the actual numbers of bets, which just required a bit of a slide rule to work out. There's some tickets. I found some tickets in a place deep in the deep south. And you can see computer people would be delighted to see that the sequence starts with 0. And so you have a pile of tickets and you take the tickets off one at a time. The number there says how many have been sold. See? Which is how they tell. And they came in bundles of 50 and the commutator had to keep track of how many bundles of 50 had been used so far. It was very hard to find out how these things worked. It was never written down, but I found it in the scandal sheets. So there's a newspaper in New Zealand called The Truth, and this is one here is an article about a court case. The police tried to shut down the Totalisator, and the tale of a tote tangle at the trots, and the detectives are dubious and talk of tote trickiness. And in there's a description of how it worked. It was really a perfect quadrinary tree of adders. They're all humans to work out the totals. And it's something which could handle quite large numbers of ticket machines. This is the only picture I've ever found of the inside of one of these machines. And you can see the people selling the tickets. There's the tickets up above there, so you can see the numbers clearly. And I think the computator here has stepped to one side, but down here you can see a guy who's adding up numbers and another one behind him. Down the back there's a blackboard, and up the top there's somebody who's operating the display. Okay. So that was a totalizator machine without any machinery. If you go around New Zealand, you find that there's these old buildings all over the place and old racecourses, some of which are still used, some not, and magnificent buildings. Some of them are very well maintained. I've found about 25 of them. I've been to every racecourse in the country looking. A particularly nice one is at a place called Hokitika on the west coast, which is a lovely octagonal building with a display in front there. It's covered up. Inside that building, you see some of the equipment they use to display the totals, and the grand totals here were displayed on these, and later on they displayed expected dividends with these other devices. A couple of years ago I went to the most southern racecourse in the world at the bottom of New Zealand, at a place called Riverton, and they had a slightly different way of displaying the expected dividends there. You can see them. They were win in place. We'll discuss that in a second. But it's amazing. It's all computerized nowadays, and all the expected dividends are on the screen. And behind the screen, this panel here, there's a guy sitting there looking at the TV screen and moving these things up and down manually to show people what the expected results are. Old habits die hard, but down in the deep south of New Zealand. Okay, these manual totalizators worked very well if they were managed well, but if one of the rules was that the totalizator had to be completed before the race could start. And this could cause troubles if people were slow in the totalizator. And there's a story there about how everybody who had a winner on the last race missed the last train home and had to walk home instead. Okay, so there was a need for automation. It should have scaled up, but it didn't. In New Zealand, the clubs had the monopoly, so they had the money to spend on automation. And that's what happened on the bigger race courses. On the smaller ones, it wasn't really automation until the 1950s. Okay, that brings me to the second person who's important, a guy called Sir George Julius. He's an engineering graduate of Canterbury University in New Zealand. His father was the chief bishop of the Anglican Church in New Zealand. He was an engineer, and he started a consulting firm in Sydney. He designed a device he thought was going to be for voting, but it didn't happen very often, so he found an application where people had to vote more often, and that was at the racecourse. So he adapted his device for the Totalisator, and he founded a company called ATL, or Automatic Totalisators Ltd. The first machine he introduced or made was built during 1912 and set operating in Auckland in 1913. The local newspaper reports that on Monday of that weekend, we have Easter Monday off. 83,000 bets were handled by the Totalisator machine, about 10,000 per race, which is adequate for that particular race course. He had 30 ticket stations, and they could handle about 10 bets a minute if they were fast. And it was at that speed there, that's about the maximum speed the thing could run. And it seemed to work. There's the picture of the first Totalisator machine. The machinery is back in behind here. Okay. You're seeing through little portholes here. The figures, you can't see them of course, but you think of them as being there, and they're actually on the machine itself. This is interesting because in a lot of race courses like this one, the upper classes are on this side, and there's a barbed wire barrier down the middle here, and the lower classes are on this side, but they're all betting on the same horses. Okay, how did it work? Well, the big idea that Julius had was to represent the number of bets by the rotation of a shaft. So a shaft, if it rotated fully, it represented 20 bets. And that's the way he represented all the totals. The problem he was facing was the simultaneity. The idea was that 30 of the machines could have registered a bet at exactly the same moment. So how can you be sure that you actually add 30 onto the total? It could be on the same horse, and it certainly on the grand total could happen all at once. So he had to convert the parallel sails into the serial rotation, and the device he used was this shaft adder. And we've got the two shaft adders here, one over there, post-war one, and one in the lobby from the 1920s. It involved a thing called a differential adder. And I try and describe this to people, and you would have no trouble with this, most of you. You remember when cars had rear-wheel drive, and you would could jack up the back and get the engine going, put it in gear and low gear, and the back wheels would rotate. And then you could grab one of the back tyres with your hand and stop it. And this would be compensated for by the other one going twice as fast, right? And another way of looking at that is that the rotation of the two back wheels added together is the same rotation, maybe with a factor on it, of the drive shaft. So a differential can actually add. If you turn the engine off and then turn the wheels to represent the bets, then the drive shaft would be the sum of the two. Okay. So that was the idea, and Julius put this in a shaft adder with not just one differential, but a whole chain of them. The centre differential is being driven to rotate, and the other ones have escapements, which are like in clocks, and so they're stuck and they can't move, and when the escapement is operated, it allows that particular differential to move, and they all can move at one time, and the centre one represents the sum. Okay, Julius only ever wrote one paper, which was a surprise, in 1921 or something, and that was a picture from his paper, which describes what a chain of differentials looks like. There's some complications to it, but I say really it's a parallel to serial converter. Okay, some details of the Ellerslie machine. Look, I just look at the pictures, eh? So you can see how big it was. It could well be that this guy here is a junior apprentice, just a teenager, but all the same, it's a big machine. It's real hardware. And these display wheels here are what you see through the windows at the front. They give the total for each of the horses. And at the top there, the grand total. This is a view that what I started off with, and I can now tell you that this here is the shaft adder for one horse. Initially, he thought you actually had to have one escapement for each ticket selling machine. So that's for one horse there, another horse here, and there's a shaft going out here to drive the drum in the front, which displays the number of bets. And what he did in this particular machine was add up the horse totals to form the grand total. So by means of bike chains, the rotation of horse adders down here were conveyed to this device up here, which was also an epicyclic adder, which would add up everything on one half of the machine and send the results up here by another bicycle chain. The two halves would be then added together on top to give the grand total. An incredible machine. The other interesting thing about it was that it was really a 19th century machine. There was no electricity. It was entirely done by clockwork. So the machine had these heavy weights at the back to drive everything forward. And there's crank handles up the top here to raise the weight. So while the betting was going on, some hefty person had to be up there making sure that the weights didn't get right down to the bottom or it wouldn't work properly. So there's the ticket selling machines, which were very primitive in those days. Each one of those handles represented the one particular horse, and you pulled the handle down and it pulled a wire, and this was connected to an escapement in the machine. And the wire was a steel wire. It had to be taut all the time. It's not electrical wire which can hang around anywhere. It had to be kept tight. And up here you can see part of the bird's nest of wires which are necessary to transmit from the 30 ticket selling machines to the actual central adding machine itself. Amazing machine. It's said to have worked. I wonder whether it actually worked reliably. But it was only there for a few years because as soon as he started making it, he had ideas as how to make it better. There were many improvements made. One of them was the use of electricity in a big way. And by the time there was sort of a hiatus for the First World War, but once he got started again after the First World War, they started to put these things out one after the other. And he had about 7 by 1919 and many, many more in 1920. And he was becoming well known, and that's when he published his only paper, A Mechanical Age to Calculation. And he maintained that if he continued with this technology, he could actually handle 1 million bets in a half hour before a race, that he could find a way of dealing with those. Well, had some extra features. Say electricity was introduced. They had electric motors to drive the adders forward rather than weights. And they had ticket selling machines which would issue the tickets with the horse's number on them, and they're connected electrically to the machine, so the escapements will work with electromagnets. And one big advance was the introduction of a mechanical multiplexer to enable one escapement to share multiple ticket selling machines. So there's one there that 16 machines are using one escapement. So these connectors up here rotate around at quite a fast rate, giving each of the ticket selling machines, the 16 connected to it, a chance to register a bet. So they're taking advantage of the fact that a bet doesn't happen very quickly. There has to be change given and argument about whether they got the right ticket or so on. So there's plenty of time to share one escapement among many. And this enabled them to make the machines much more cheaply after this. So there's a picture of a shaft adder, very like the one which is in the entrance hall of the museum. You can see these things here are clutches, so there's external power being provided to this, and this clutch slips and provides impetus to drive the adder forward. At the same time, they could actually simplify things, and so they went to having totalizators in much smaller courses. So here's one which combines the display with the adder down here. And there's a very interesting device here, which was a buffer. Because this was a high mass device, it couldn't be started or stopped quickly. So this adder would move quickly, and the rotation would be saved on a spring inside here, and then it could be released gradually and displayed. A very, very clever mechanical solutions to problems. Okay, so this is in the 1920s, and ATO was becoming a big company. They were selling these machines all around the world. They had no competition, and they tended for the big course in Paris, Longchamp, and this was installed in 1927 and set operating in 1928. It had 273 ticket stations operating in parallel. They had 2 people per ticket issue, so that they could handle the bets very, very quickly. The local newspapers called it the insatiable Moloch, because it would absorb all the money you could put into it that it would take. And it was kept going until 1973, so a long time for a machine to be in operation. Details about this machine, it could handle about 200,000 bets per race, and some of them are multiple bets, multiple units. So, you know, he's getting up to about 500,000 unit bets. So he's getting close to his goal, but he didn't quite make it. Okay. The adders on this machine were stupendous. This is an adder for 1 horse, you see. And well, despite the fact that they had the multiplexes, they still had to have a huge number of differentials connected together in some form of tree. I have no idea how it worked. It was just huge. And this is number 5, but there were 42 horses, and they also bet on places as well as wins, and had the grand total. So there were 86 of these machines, just an incredible amount of hardware. I happened to find myself in Paris last year. I allowed one day to visit Longchamp, see what was still there, and it happened to be the day of the big race, Prix de l'Arc de Triomphe. And so I took some pictures of what's still there. They don't use the building anymore, but the building's still there. It's an historical monument. This is another display which was in the centre of the field, and the ticket selling machines. And there was the fashion outside the pub there, which that's the big thing with the races in Paris as well, is to display yourselves, I suppose. The totalizators kept improving over the years and using new technology. Used relays, they used relays logic. I don't think they used electronics ever. They had bigger multiplexes, but they also introduced other forms of gambling. One of the problems with only betting on the winner is that if you can go to the races, and chances are you're not going to get a winner at all, so it sort of ruins the experience. So another possibility is to have a place bet, which is what we call a place, which you call a show, I think, which is a horse comes first, second, or third. Now, the trouble with that is that what you should get as a dividend is unpredictable, because it does depend upon what 3 horses come in. But they sort of got around it by just taking the pool of all the bets for placing and dividing by 3 and giving a third to each horse. So place betting became very popular. You could bet on a win on a horse or a place coming in the first 3. The other thing they did was, for the people who didn't like the size of the returns they got, was to have double bets, whereby you would bet on 2 horse races. So if they had 16 horses each, there'd be 256 possibilities. So you get a much bigger payout at the end. And the other thing they did finally was to realise you didn't have to display the numbers of bets. All you had to do is to give a rough idea as to the odds or the return you would receive for a unit bet. Oh, I'm not going to talk about this, but if you look into it, the way they worked out the place bets is actually very unfair to the favourites. And if you put a bet on a favourite for a place, you're going to get a very low return. So that just proves that. I'm not going to go into it at all. But they made machines which would handle both wins and places, and they would share common machinery like the motors. So this is a machine which is maybe still in New Zealand, and one side of the machine is devoted to win betting, the other side to place betting. Another thing, well, I mentioned doubles betting. The way they handled that was, rather than having 256 different things to bet on, that you bet on the first race, and the winning tickets on the first race could be cashed in for bets on the second one. So they often had a special totalisator for doubles, but they usually didn't bother with the display. So this is a doubles machine, and the machine over there is this one. So it was just a set of, I think, 24 of these adders for adding up the bets on the 2 races which were part of the doubles for that day. The really interesting thing was odds calculation. And basically, see, people didn't want to know the totals, they wanted to know what the odds were. And it could have been done by somebody with a slide rule and moving indicators up and down, but they actually made machinery to do it. It's very interesting, but I'm getting on. I've only got 45 minutes, is that right? Yeah. So essentially, they had a machine whereby you had a triangle, which the horizontal line represented the horse total, and the vertical line, the grand total, and the hypotenuse, which is there, pulls on a string. And it pulls on a string, and this causes a weight to get lifted here with a scale which is set to indicate what the expected return is. And that is also connected via a servo motor, so you see outside a display of what the expected returns are. Okay. These were only approximate returns. They realised you didn't have to say accurately, but you had to keep accurate totals. So they had attached to each machine a very accurate little counter, a very low mass, an American brand called Root, I think. Here's an example of one of these machines going in the 1940s during the war. I know my father was there, and I've looked very closely. I haven't managed to find him. But that machine is still preserved in almost going order. So it's nice to see that there's at least one remaining. Okay, the industry was huge, but after the war, all the small courses got mechanised, usually using technology which involved automatic telephone equipment. They're all mechanised by the 1960s. There were mobile totes and there were luggable totes and all sorts of varieties. But by the mid-70s, computers came along, and that was kind of the end of it, because this algorithm was then put into the computer, and the old machinery had no need at all. So companies all died, the companies which were involved with providing totalizators, and they're now just part of the gambling business in general. The only thing special about horse race gambling nowadays is the terminals which are made for it. Just to have a couple of slides on the US scene, which I know very little about. I do know that it varies from state to state. Some states banned the totalizator, some had it. I suspect you had small totalizator machines and manual ones, but I don't know anything about that. I know the automation didn't take place until the 1930s. It was a lot later. The first mechanical tote was in Miami in 1932, and that was an Australian machine. The only book written about the subject was American, by a guy called Fred Buck. It's very interesting to read how they ran it. But the most interesting thing is that there was another company called American Totalisator, Tote, and it was founded by a guy called Harry Strauss, who was a Baltimore engineer, and he designed totes using telephone technology. And they appeared to be much more modern than the ones from Australia, which were designed with mechanical equipment, and just because they were 20 years later in their design. And that's Harry Strauss himself, and he designed his Totalisator machines. He couldn't find a market in the States because they were banned, but in Britain they decided to open up the Totalisator business, and he went into cooperation with a company called Bell Punch, who made the ticket machines, and they got part of the British contract to provide the Totalisators there. The first site he had in the US was in Chicago in 1933. He negotiated a percentage of the takings and became a very wealthy man. What's particularly interesting about him is that he looked for other places to invest what he had gained, and he became the financial backer for Eckert-Mauchly Corporation when they were building the Binac and the Univac. And he was chairman of the board of Eckert-Mauchly there in the late 1940s. But he died in a plane crash in 1949, and Tote pulled out, and so Eckert-Mauchly had to look for finance elsewhere and got associated with Remington Rand, and the whole of computer history was changed. But it is an interesting connection between the Totalisator and the computer business. But that's about the only one there is. Okay, so that's about all I've got. Being at a university, I've got to say I'm doing research, and one of the things is field visits. So I've done Paris, and now I've still got a few to go to in Australia, and Tasmania, Western Australia. I have a website which describes all I've found, if you wanted to have a look at that. I want to write about the history of the introduction of the tote in England, and there are other tote companies. I mentioned that some totalisators used ball bearings or marbles to represent bets, and they're fascinating. So I'm trying to find more about them. And I occasionally experiment, do a practical by going to the races and back a medium outsider for a place. And so I do occasionally get a winning, but not very often. So that's my talk, and I can take questions now.
All right, thank you, Bob. We have just a few short questions here. The first one is about the situation in France in the 1880s. I believe you said that the Pari-Mutuel betting system was banned.
That's right.
But there was a system already in place before then.
That's right. Betting was banned entirely in France, in horse races, but it happened all the same, and it was illegal. So they had bookies running gambling. And then this was completely out of control, which is why they eventually decided to allow Totalisator, and Ollier got back in charge of it again. So, yeah.
The second question is about the payoff or the payouts and how they actually happen. The adders calculate the totals, but how does the division at the end of the race actually happen to calculate the payoffs?
I assume it's done by long division by hand. Back in the times of these totalisators, there were a lot of people who could do mental arithmetic or arithmetic by hand, and they may have used a slide rule, but I think it would be done by hand. Yeah. Accountants in the first part of the 20th century are amazing people. They could add up whole columns of numbers in their heads and do mental divisions and all sorts. You know. And it was a job they had on the weekends, right?
Now, related math questions. You showed the triangles and how they would do the odds calculation. Yeah. Maybe you can go a little bit more detail on how the math actually happened there, how the division happened with the triangle.
Well, because you've got a right-angled triangle, you have the horizontal is the horse total, and the vertical is the proportional to the grand total. And this means that we're doing a division. that forms the tangent of the angle. So taking the negative of the tangent, you get the angle. So the angle itself is proportional to the dividend. And I think they just set it up and then worked it out and inscribed. They may have used mathematics, but they didn't have to do it. They could just put different combinations and mark them off on the scale. So it was quite a complicated mathematical transformation, but they didn't have to do it. They just had to know where to mark on the scale.
Can you talk about where the machines were manufactured?
Yeah, the ATL machines are all made in Sydney. Yeah. That's the only one I know about. The British machines were made there in England somewhere, I suppose. But it's very sad that all of the post-war machines have gone. There's no remnants of them I can find anywhere. And they were the ones that were built using automatic telephone equipment.
Have you been able to find out anything about the people who actually manufactured these machines, what they were trained in? Were they simple mechanics? Was there an engineering department that did all the calculations? Was this all George Julius's work? Yeah.
No, I think there were skilled fitters and turners. And people can make all those gears. Beautiful job. As far as the design goes, there were particular people who designed very important components of it. Some of them got credit, some of them didn't. The guy who invented the ticket machines was a person called Setright, and he then split up with Julius and went to Europe and set up his own company. But one of the things I do want to look into in Sydney is the archives for that particular person. So the ticket machine was almost a bigger design job as the actual totalizator itself, because you had to record the bet and print the actual ticket with the horse number on it and so on as well, and do that very reliably and accurately.
Was there any connection with these designs to stock market or financial applications? Are you aware of any crossover into that world at all?
No, none at all, as I'm aware of, no.
Great. Well, I think that's it. Are there any other questions? Do we have anything else? All right. Well, thank you, Bob, very much for a fascinating talk.